Dear student, today we are going to discuss about the class of transistor. From the last few class, I think you have very clear idea about semiconductor, extrinsic semiconductor, intrinsic semiconductor, how p-type and n-type material is formed. Using this p-type and n-type material, how p-n diode can be obtained. So from before the classes, we have the consequences, that is the major electronic device transistor is going to be discussed. So first of all, we would like to know what is transistor. Transistor is electronic device which is consist of two p-n junction that is formed by sandwiching either p-type or n-type semiconductor between a pair of opposite type. From the figure you see that NPN transistor, middle element is P and opposite N-type and P-type is sandwiched. Similarly, from the another figure we can see that the middle component is N-type and other side opposite type of semiconductor material, that means p-type and n-type, p-type is sandwich. So this is how the transistor formed, by sandwiching p-type or n-type between a pair of opposite types. So from the figure you can see that there are two types of transistor, one is NPN and another one is PNP transistor. So each type of transistor has some point. First of all, there are two p-n junctions. From the figure you can see that, considering NPN transistor, there is a p-n junction between N and P and another p-n junction is P between P and N. So there is one p-n junction and there is another p-n junction. So there are two types of p-n junction. Similarly, for PNP transistor, there is a p-n junction between here P and N, and there will be another p-n junction between N and P. This is the first point. Second point is that both of these transistors have three terminals. Three terminals means here is one terminal, second terminal, and it is third terminal. Similarly, first terminal, second terminal, and third terminal. From the figure you can see that this is a practical view of that electronic device. A transistor has three pins, that means three terminals, 1, 2, 3. Each of these terminal has a name. That means one is called base, one is called emitter, and one is called collector. That means each of the transistor, both PNP and NPN, has three terminals: emitter, base, and collector. Let's see, from the figure we can see that, considering PNP transistor, the sandwiched material which is in the middle is called base, and left side is emitter and right side is collector. Similarly, for NPN, middle is P, so it is considering as base, left side is emitter, right side is collector. So from this slide we can know that a transistor has three terminals: emitter, base, and collector. So three types of terminal: emitter, base, and collector. What is here? This is the PNP transistor. This side is emitter, base, and collector. Emitter is the section on one side that supplied charge cache. That means emitter supplies electrons or supplies the charge. And emitter is always forward bias with respect to base. That means emitter and base always in forward bias. From the figure we can see that for PNP transistor, this is a PNP transistor, the emitter of the PNP transistor, this emitter of that PNP transistor is forward bias. Here you can see it is in forward bias because P type is connected with the positive terminal of the source and N type is connected with the negative terminal of the source. That's why it is called forward bias. So the emitter of this PN junction is in forward bias and supply the current, whole current, to the junction of the base. Similarly, from NPN transistor, we can see that the emitter is in forward bias because negative is connected with the negative polarity and positive is connected with the positive terminal. That's why it is in the forward bias. Number 2 is collector. The collector section is on the other side. It collects the charge. That's why it is called collector. Emitter emits electron and collector collects electron. And point to be noted that collector always is reverse biased, but emitter always forward biased. And another section that is called base. The middle section is always called base. This middle section, which forms two PN junction between the emitter and collector, is called the base. That means this N is responsible for this junction and this junction. So the material which is between the PN junction, that is called base. So I would like to remember again that base emitter junction will be on forward bias with low resistance, and base collector junction will be in reverse bias, which provide high resistance. So in a nutshell, we can say that transistor is consist of 3 extrinsic semiconductor. 2 of them will be same and another one will be opposite. That means and same type of material is sandwiched with opposite type of material, which is formed transistor. It has 3 terminals: emitter, base and collector. It has 2 junction: emitter base junction, another one is collector base junction. Next topic, transistor action. So this is NPN transistor and this is PNP transistor. We know that emitter base junction is in forward bias, reverse bias junction emitter base in forward bias and collector base junction is in reverse bias. So emitter emits electron and collector collects it. Okay, so from this figure you can see that NPN transistor, this is an NPN transistor. Here N and P is in forward bias because N is connected with negative and P is connected with positive. It is in forward bias, and collector base junction is in reverse bias because P is connected with negative and N is connected with positive. So this junction is in forward bias and this junction is in reverse bias. The forward bias cause the electrons in the emitter to flow towards the base. That means we know that in the forward bias there will be an external current flow. The current will flow positive to negative terminal. That means current flows from base to emitter. So this emitter current is known as IE. Subscript E is for emitter and I is for current. And similarly, the collector current, that means the electron emits by emitter, collector collects it, so that electron flow is called collector current, and which is also from positive to negative. So finally, in this point we can see that there is a two coming current, that means IC is also incoming, IB is also incoming, and outgoing current is IE. So finally we can say that IE equal to IB plus IC. That means emitter current is equal to base current plus collector current. This is for NPN transistor. If we consider the PNP transistor, what will happen? So this is the PNP transistor, base emitter junction, collector emitter junction. P type is connected with positive and N type is connected with negative. So this junction is in forward bias and this junction is in reverse bias. So similarly, as emitter emits the electron, the current will flow from positive to negative towards base, and for this kind of polarity the current will also flows from positive to negative. So in this point we can see that incoming current is IE, outgoing current is IB and IC. So finally we can see I equal to IB plus IC. So for both of the two cases, emitter current equal to base current plus collector current. But point to be noted that for NPN transistor base current is outward, and for PNP transistor base current is inward. Next is the transistor symbol. This is the symbol of the transistor, or this is how the transistor is symbolized. This is NPN transistor, and from the just a slide before or ago we can see that we already saw that for NPN transistor current will be base current will be inward, and for PNP base current will be outward. In another sense we can say that the current will be flow from base to emitter, base current incoming, outgoing through emitter. For PNP, I is the incoming and base current is the outgoing. So based on this flow of the current, the symbol is described like this. This emitter, this is base, and this junction, this point is the, or terminal is the collector. So as consecutive of this figure we can say that base current is incoming base current, I is outgoing, I is outgoing. So this arrow shows that the current will flow from base to emitter, that's why it is PNP. Similarly, incoming current is I and outgoing current is IB, so current is coming from I and goes to IB. So this arrow symbol shows that current flows from I to IB. So this is how the PNP transistor symbolized. This is the symbol of NPN and this is the symbol of PNP transistor. Now next topic is that transistor circuit as amplifier. That means we are going to describe that how a transistor works as an amplifier. This is a very crucial and very important application of the transistor. Basically the transistor used for amplification various kind of signals. So now we are going to see that, or we are going to understand that how transistor circuit works as an amplifier. From the figure you can see that this is an NPN transistor, NPN, that means emitter is N, base is P, and collector is also N. This N is connected with the negative, base P is connected with positive. Similarly, base P is connected with negative and another one is connected with positive. So this is how the base emitter junction is in forward and collector base junction is in reverse. So this is how the connection is set, and we give the input in the base emitter junction as it is in forward bias. We are giving here an input signal C. From this point we can set I equal to IB plus I. First of all, assume that there is no signal is here. Generally the line is connected with the source VEE. Okay, so we can get from this point I equal to IB plus IC. When we add here an signal, input signal, definitely there will be some increment of emitter current, because VE has a fixed voltage, it produces a fixed current I. When we add another signal, definitely there will be some change of emitter current, and obviously it will be increased. For example, if it is increased 0.1 milliampere, that means 0.1 milliampere, we assume that there will be change in collector current, because we know I equal to IB plus IC. So if I will be increased, definitely there will be change in collector current IC. So the collector current will be changed. So we consider that the change is also 0.1 milliampere, and in the output side, that is collector side, a load is connected, that is RC, whose value is 5 kilo ohm. So will be the output voltage. Output voltage will be, if we consider that 0.1 milliampere is changed, so the voltage will be 0.1 multiplied by 5 kilo ohm, so it will be 5 volt. So you are giving here a very small input signal which will be 0.1 volt. We are getting here 5 volt. So how many times it will increase? Near 50 to 500 times. So this is how the transistor circuit works as an amplifier. Next is the transistor connections. So we have learned before that transistor has 3 terminals. Number 1 is emitter, base and collector. However, when a transistor is to be connected in a circuit, we require at least 4 terminals. That means 2 for input and 2 for output. But unfortunately we have only 3 terminals. So what will be the difficulties? Difficulties will be making one terminal of the transistor common to both of the input and output terminal. For example, 3 terminals we have, emitter, base and collector. If we make emitter common, so there will be other 2 will be input and output. If we make base common, emitter and collector will be input or output. So according to this, the input is fed between this common terminal and one of the other 2 terminals. For example, considering common base will be common, emitter and collector will be input and output. Considering emitter, when emitter will be common, base will be input and color will be output. So for this consideration, or according to this way, transistor can be connected in a circuit following three ways: common base connection, which is called CB connection, common emitter connection, C connection, and common collector connection, CC. So next lecture will be on common base connection.